Today's video is all about this oxyacetylene torch. I'm going to run it on propane and compressed air instead of using the usual acetylene and oxygen. So I'll have a quick look over here. There's the propane bottle and regulator, and there's the compressed air line. And we'll have a go and we'll see how well it runs. See what happened? Blows the flame out. We'll try it again. See what's happening? The flame is actually getting pushed away from the tip, and the more air I put on, blows it out. So obviously there, you can't run acetylene torch with propane and compressed air, so I'm going to have to modify it. As you can see, with the acetylene torch, it didn't like the compressed air. It sort of went out, so what I'll be doing, I'll be making a flare for the end of the pipe, this part here, so it'll slow down the burning of the propane and air and hopefully keep it inside here and make a stable flame. So I'll be using second-hand materials. So what I've done, I'll be using this flare nut, and there's a flare on the end of that, and I'll be putting a washer on the end of that so it'll seal. Don't want propane leaking everywhere. And I've straightened this out. It had a lot of bends on it, but it's good enough. It's a bit rough, but it'll do for what I want to do. Here is a close-up of the drawing I've made. I'm going to use the burner for the oxyacetylene torch. Now here is the length. It's 64 millimeters from there to the end. So it's not exactly a precise measurement, so you can go from here. We've got plus or minus 0.5 of a millimeter, so you can use a ruler and eyesight, and then we go around, turn this around to here. So we've got 35 millimeters inside diameter. The outside diameter doesn't matter. Same thing again, 0.5 of a millimeter above or below. It's not that exact. Then we go back to here. This is the more important dimension. This is the jet or orifice. That's 1 millimeter drill going through there. That's got to be very close. I've cut the thread on the end of the pipe with the lathe, and we'll see if it fits. Yep, fits no problem at all. Here it is, ready for the next step. Here is a close-up of the pipe. You can see the flare nut and the flare on one end. On the other end I've cut the thread on the lathe so it fits inside the oxyacetylene torch. Here is the flare, it's been finished, but while I was drilling the hole from this side for the thread, I accidentally broke through that wall, and what's happened is now it's 1.35 millimeters in diameter instead of 1. So I thought, well, I'll try it. So I made an aluminium washer in there and put it in, and I'll show you what happened. It tended to burn on one side. You can see the heat scorch marks. It went on one side and it should be all over. Now this is what is intended to happen. You've got to have the burning part of it inside to contain the flame so you get a stable flame that'll burn properly. This is the threaded end of the burner, and just there is the old washer that I made with a large hole. So now I've drilled a hole in another washer and you can see it just in there. That is 1 millimeter in diameter, so the thing should work a lot better now. So I've assembled the burner onto the oxy torch. What I'll do, connect up the compressed air. Like so. And what I'll do, I'll run it very slowly at first and see how stable the flame is. Then afterwards we'll give it a really good run. So that worked really well, but I'll demonstrate something else for you. Now, did you see what happened there? It almost stopped burning, but it still pushed through. If you're afraid of the flame going up the pipe, it just will not happen. As you saw when I started it, the propane is blown out by the compressed air, so it will run only outside the burner, never inside the pipe anywhere. As you can see, the burner worked really well. But I know someone's going to ask the question and say, I want to build a bigger one. Well, if you do, you'll have to use a larger jet or orifice size, and when you do that, the length and the diameter will have to change because it's larger. And the second question I know someone's going to ask, can I shove that in a furnace and melt metal with it? Well, I've never used it for that. I don't know what will happen, but the problem is this is run by compressed air. I use a vacuum cleaner, so with this type of burner you might be stretching your compressor a lot, using it too much. And third question I know some people are going to ask is, what was the propane pressure? Well, I had a look on the regulator and it's about 150, I think, to 200 kPa, which is not a great deal of pressure. You don't need to force so much gas through it, and the air pressure was about a little bit half of what the propane pressure was, so probably about 80 to 100 kPa. So to finish up the video, I was going to ask you a question about propane. Now, I suspect why that flame was going out is because propane burns a lot slower than the acetylene. Now, I'm not sure. If you know more about it, please put it in the comments. Does acetylene burn a lot quicker than propane?